What happens when AI models use AI-generated content to train themselves? Do they get exponentially smarter? You'll find out right now. Welcome to the channel. If you're new here, my name is Hong and I am fascinated with software and intelligent systems. I'm currently a senior software engineer at Amazon and I received my bachelor's, master's, and PhD in computer science. In these videos, we'll look at the latest AI breakthroughs, we'll discuss their implications, and we'll explore how they might shape our future. So now, let's get started. This paper comes from researchers at some of the world's top institutions, including the University of Oxford, the University of Cambridge, Imperial College London, the University of Toronto, the Vector Institute, and the University of Edinburgh. You can find the full paper in Nature issue 8022. Link in the description below. To understand the experiments that were performed in this paper, let's think about how large language models are created. So for instance, you put together a massive training data set. So for instance, you scrape all of Wikipedia, scrape all of the public internet, every textbook ever written, every nonfiction book ever written, every story ever told, and you create a model which is able to generate text that is similar to everything that it has seen before. So for example, let's say you give it the calculus textbook, and you also give it the Lord of the Rings. So that is part of the original training data set. And once you have your first model, let's say instead of giving it the original text all over again, instead you tell your model, please write from scratch that calculus textbook and also retell to the best of your ability the full story of Lord of the Rings. So what you'll then have is a new training data set, which is comprised completely of generated analogs of the original training data set. So if you take all that training data and then you use it to train yet another model, what you can do is just keep repeating this process. So you use that model to generate yet another retelling of that textbook and the Lord of the Rings. And then you train that to create a new model, use that model to generate another copy of the Lord of the Rings and that textbook, and just keep repeating this. So after doing this for several generations, so you have a series of models, what you'll find is that the models will progressively get worse and worse in what the authors are calling model collapse. So what is model collapse? The authors break it down into two flavors: early model collapse and late model collapse. In early model collapse, imagine you're a visitor to Los Angeles and you're trying to learn everything there is about the city. However, you do this only by visiting the most popular spots. This is early model collapse. So you will miss out completely on the hidden gems and the local secrets. So the nuanced and rare information in your data set, this tail of your distribution, is slowly going to disappear and you'll lose the diversity of your data set. So what is late model collapse? Imagine the data loss and errors during early model collapse compounds over several generations. So this is like a game of telephone or the board game Telestrations. After several generations of this, the end result is nothing like the original data set that you did your training on. And similarly, the large language models that are created based on the later data sets are significantly impaired. The scary part of this is that the authors suggest this is inevitable. Given enough iterations of AI model training, if access to the original human-generated content is not preserved, then you'll slowly lose information about the long tails of the distribution, so rare events and outliers, and that will just compound. To give a concrete example, an excerpt from the paper, this is an output of a passage in their Generation Zero model. Quote, "The earliest surviving example of perpendicular revival architecture is found in the 18th century Church of Our Lady of Guernsey." Now, that same passage as recreated by a model 9 generations further. Quote, "In addition to being home to some of the world's largest populations of black jackrabbits, white-tailed jackrabbits, blue-tailed jackrabbits, red-tailed jackrabbits, yellow-tailed jackrabbits, etc." Yeah. So what are some of the implications of this research? Well, for the companies and entities creating large language models or AI models in general, right now there's an first mover advantage. So a lot of the content is going to be, or rather a lot of the content of the training data is going to be human generated. But as AI models become more ubiquitous and more commonly used amongst the population, there's going to be more and more AI generated content that pollutes the general training data or when doing data collection. So what that means is that there may be more volume of data in the future, but human generated content may become more and more scarce and valuable. Another thing that might happen is that as AI generated content becomes more and more difficult to distinguish between human generated content, is that some companies or entities may push for more implementations of things like watermarking in order to more easily tell the difference between the two. Right, that's it for this video. Thanks for watching and congratulations to the authors on an excellent paper. If you liked this video or found it interesting, feel free to hit that like button because it helps me know what kind of content you enjoy and helps me continue making stuff that matters to you. Thanks.